Hello students, and welcome to this unit on parallel lines. This will be Unit 3. So, very interestingly, our very first lesson here is going to be about parallel lines cut by a transversal. So, before we can get into this lesson, we need to know some vocabulary, right? And our objective is that we are going to generate conjectures about parallel lines cut by a transversal using an exploration activity and journal notes. So, there's a lot of words in there, right? We already know conjectures, we know about parallel lines, and now we have this other word, it's a transversal. So I actually want to go ahead and define parallel lines again and the transversal so that we all have a common operating picture. So for our purposes today, we're going to define parallel lines as two lines that lie in the same plane but do not intersect. So that's very important. A really key thing here is that they are in the same plane, right? So we would draw them as two straight lines that do not intersect. Interestingly enough, we can also have another definition called a skew pair, and skew pairs are two lines that lie in different planes and do not intersect, and we'll get to those later. But for now, let's go ahead and define the transversal. The transversal is a line that intersects two or more lines at distinct points. And this is kind of just in general, right? So if I have two lines here that just kind of exist in the universe, and it doesn't matter if they're going to intersect or not, but I can use this in a very helpful way that will help me define some things. So we say that we have some line, the transversal, which will cross these other two. And I'm actually going to change where this diagram is located. If you guys have a little bit more space than me, actually I'm just going to leave it here. So we define then the interior and exterior as the interior is the space between the lines. And then we have the exterior is going to be all of the space, and let's go ahead and use a nice little color coding here. All of the space which is outside of that pair of lines. So that's going to be the exterior. And the interior is all of the space that is between the lines. And that makes sense intuitively, right? The interior is the space between our two lines. And then our transversal is this purple line, which is intersecting. So now that we've defined a transversal and we've defined parallel lines, there are some very interesting things that will happen with the angles in a pair of parallel lines cut by a transversal. And so now we can start to make conjectures about parallel lines cut by a transversal. So for this, we're going to need our cutout that we've got going on. So the reason why I kind of compressed this right here is that we're about to take this cutout and you're going to paste it in on this page. So you're going to go ahead and paste this in there. Okay, now that you're done pasting that cutout in there, let's go ahead and talk about all of our different postulates that we're going to have here. So let's talk about corresponding angles. So corresponding angles are those angles which will share a similar position in relation to the vertex after the cut. So if we're talking about this as the vertex, then the corresponding angles will be the ones that are in the same orientation in relation to the vertex. For instance, this is the upper left angle from the vertex. Therefore, we have some relationship between our corresponding angles. And what we'll see is that our corresponding angles, those ones that share the same relative position, they are congruent. Now we also have to ask ourselves, how many different pairs of corresponding angles do I have? Well, I have this blue one, I have this red one, then I also have this green one, And finally, I also have this orange one. And I'm actually going to use a different color other than orange here. I'm going to use this kind of, I'll just use black here for the highest contrast. So we have 4 different pairs of corresponding angles. We also have something called an alternate interior angle. And when we're talking about the alternate, right, we're talking about alternating across this line. So it's alternating across the transversal. So whenever we say alternating, it means in relation to our transversal. Interior, right? We already know what interior means from our last page. So it has to be somewhere within here, and it has to be on opposite sides. So my first pair of alternate interior angles will be this and this. And what we can say about alternate interior angles is, again, they are congruent. And here I have 2 different pairs. I have the red pair and I have the blue pair. Alright, and now we get to our next one. This is same side interior angles. Again, this keyword here, right, this alternate and this same side, we're talking about the transversal there. So we're talking about angles that are on the same side of our transversal. So we have our red ones, and now I'm going to use a double mark here because we're about to say something interesting here. So what I'm going to say here is that same side interior angles are going to add to 180, or are supplemental. Well, that's pretty neat, and it looks like I have one set there, and then additionally I also have this set on the other side. So the red angles will be supplemental and the blue angles will be supplemental. So now we come to vertical angles, and vertical angles, we need to remember, they are those angles which are directly across a vertex from each other. So they have to be on the same vertex. So for instance, this is a pair of vertical angles. This is a pair of vertical angles. We also have our purple angles here, which are vertical angles. And then we also have our green ones here. And we can say that vertical angles are, well, they're going to be congruent because we already knew that from our previous knowledge, right? We knew that vertical angles had to be congruent. All right, now let's talk about alternate exterior angles. So that word exterior means that we are outside of these lines. So I can ignore everything within the lines here. So alternate exterior angles are going to be congruent to one another, which means that they have the same measure. And then finally, we have same side exterior angles. And so that's going to be this angle with this angle. And then we've also got, on the other side, this angle with this angle. And what we can say then is that same side exterior angles are going to be supplemental or supplementary. And again, that means to add to 180, right? That supplementary or supplemental means that they add to 180 degrees. So the blue angles will go together and the green angles will go together to do that. All right, so the next thing that you need to do is you need to go to the next page and you need to draw this diagram. And what we're going to do is we're going to label this as angle 1, angle 2, angle 3, angle 4, and then angle 5, angle 6, angle 7, and angle 8. And what I'm going to say is that this is line L, and this is line M, and I can note that line L is parallel to line M, and I can say that this line, T is transversal. So after you've drawn this diagram, what you need to do is you need to move on and do your reflection. So our reflection is you have to identify all of the pairs in that diagram of corresponding angles, vertical angles, alternate interior, alternate exterior, same side interior, and same side exterior. So do all of that, make sure that you get your check, right? Get your little like mark here, and then once you've been checked, copy these into your journal notes. So this is going to be your last bit for today. If you have any questions, please let me know, and have a wonderful day. Goodbye.